Alright guys, here we go. This is the first homework for calculus A, B, and B, C. So chapter 2.1, I'm going to do problem number 9, 31, and 50. So problem number 9 says determine the limit by substitution. Remember, there's three ways to solve a limit. Substitution is always the easiest way. So you take this 1, you plug it into there, you get 1 cubed plus 3 times 1 squared minus 2 times 1 minus 17. We get 1 plus 3 minus 2 minus 17. So what is that? 4 minus 2 is 2 minus 17 is negative 15. So our answer is negative 15. Always the easiest just to substitute it in. Now we're going to show graphically and prove it algebraically. So what we need is we need our calculator. So the first thing we're going to do is we're going to plug in our equation into there, clear this out. Remember, alpha y equals gets us a fraction. On the top, we're going to put sine of x. On the bottom, we're going to do 2x squared minus x. We graph this. What we want to do is we want to plug in points really close to 0 on either side. So if we look right here, it looks like if we press trace and plug in 0, we're going to get undefined. So remember, we have our table set up so that we can plug in anything we want. So good numbers to plug in close to 0 are negative 0.1, negative 0.01, negative 0.001, positive 0.1, positive 0.01, and positive 0.001. So negative 0.1, enter. Negative 0.01, enter. Negative 0.001, enter. Looks like it's going closer and closer to negative 1. Plug in 0.1, 0.001, 0.0001. And then just to be absolutely closer, we go really, really close to 0 and check it, we get negative 1. So to me, that tells me that the limit of this is negative 1. That's doing it graphically, but then the directions say to prove algebraically. So we got to remember our limit rules, and we take this limit and we can split this up. We factor out the bottom, and we get the sine of x over x times 2x minus 1. Okay, and so that's just using a little bit of algebra. Then we use our limit rules, and the limit rules say that if we have two things being multiplied together, two functions being multiplied together, we can separate them. X approaches 0, we got sine of x over x times the limit as x approaches 0 of 1 over 2x minus 1. See, that times that equals this right here. So remember, we did this one as an example. Sine of x over x is equal to 1. As the limit as x approaches 0 is equal to 1. Then we plug in 0 into here. 1 divided by 2 times 0 minus 1, which is negative 1. And so we just proved it algebraically also. Okay, so there's show graphically using our t-table, and then prove algebraically. Now, these are going to be all over your next test, so you want to make sure you know how to do these. The trick is being able to read this. The limit as x approaches 2 from the left-hand side of g of x. That's our equation g of x. So we're going to approach 2 from the left-hand side. So remember, this is us walking on the graph towards 2. Where are we going to be when we get closer and closer to the x value closer and closer to 2? It looks like we're right here at 1. Okay? That's from the left. It looks like it's 1. From the right, it looks like it's also 1. Okay? Therefore, since the left is 1, the right is 1. Therefore, the limit as x approaches 2 of g of x will also be 1. Okay, and then g of 2 equals, g of 2 is 1, 2, 3. G of 2 is 3 because that's where the solid dot is. Okay, and this is going to lead us into our next chapter when we got limit. The limit as x approaches 2 does not equal g of 2. That tells us that that function is discontinuous. So that's just a little like lead into the next chapter. All right, guys, I'll see you guys tomorrow in class. Thanks.